All right, we're all zoomed into Unity now. It should make things easier to see. Notice I'm actually already running a scene. This is the same gray scene we just saw a moment ago. Nothing interesting going on yet, not very much in my hierarchy, but I'm going to turn on the sensor venture scene on my phone, and we'll see much more interesting data all of a sudden. So these are all the sensors that are available on the device I'm running on, which is a Nexus 6P. It has most of the standard API sensors, with a few of them missing, like the heart rate monitor, but almost all 25 of them. And then a few hardware-specific ones. You can see that they have a type ID that's outside of this 25 range. That'll make more sense in a second. But these are defined by the specific hardware. One device to another will have very, very varying range of what's available in here. But if you knew what your device had available, or developing for a particular device, you could get those sensors that are only on that device using this. So, the only really interesting ones here are the this is an internal temperature gauge. These three are looking into it, were planned for the device and then canceled, so they don't actually do anything. And then window orientation. This is really the screen orientation. So while it's reporting 9 values, only this first one's interesting, and it's really telling you what the orientation of the screen is. So 0 is portrait. You'll see this repeated right here down to the left. But, 1 is landscape left. 2 is portrait upside down, and 3 is landscape right. But as I said, this is a hardware-specific sensor. This orientation value is accessed differently through the sensor dev system, and would not be specific to this hardware sensor being available. This should almost be available on almost any device. We see over here in the hierarchy all these sensor state networked clone. Those are the actual spawned objects that are being used to serialize all of these values. You can see the text here stopped. That's because my phone has gone to sleep. If I start it again, we'll see all these values start changing again. But if I click on one of these, you can see it over here applies to a particular sensor. In this one, it is a light sensor. I think if I pick the first one, it should be accelerometer. And sure enough, accelerometer. So we can see how this is. We can see this working, but how would I actually use this in a game? How do I set this up to get the sensor values? We'll try to make that very, very easy. We're going to look at the script being used for that scene we just saw. Here it is. It's called sensor text, and I'm going to go up to the start method. So in the start, I call update constant data, which I'll look at in just a second. It's down here, but that's for setting all of the constant values for the sensor, like its name, vendor name, version, amount of power being used. All these values don't change for a particular sensor. They're constant. But right after I call that method, I call sensors.startSensor, and I pass it sensor type. So sensors is a singleton architecture. It builds or instantiates the correct object based on the platform we're running on. So if we're running on actual Android versus Unity editor, it's going to instantiate a different object and get you values slightly differently. But that's all outside of the general user's need to know case. So you just sensors dot and start calling functions. So all the constant data can be queried at any time for any sensor that you have available, but the actual updating the values of what the sensor is reporting, those will only change if you've called start sensor. Of course, there is a stop sensor as well, which can be called to reduce power. Last thing here, though, is this sensor type, telling it what sensor, in this case, we want to start, or if you're looking down below, where we're calling down here, we're saying get name, using that same value, this type value to tell it which sensor we want. I'll actually scroll up. Sensor type here is being set to this enumeration, type underscore accelerometer. And that's defined in sensor platform base. So that sensor singleton I was speaking of previously, that inherits from this class. We can see it's abstract class. You can't define this thing. You don't have to worry about that at all. But sensor type, and we have the 25 Android API sensor values types available, all enumerated for you. So accelerometer, pressure, ambient temperature. I think that one's deprecated. Tilt detector, pickup gesture. Whatever one we need, you can query it directly using these IDs. If you're not sure what sensors are available on a device, there's also a method for getting a container of all the IDs of the available that are available for the particular device. So once the system's run on your device, it actually fills out this available sensor IDs with just the ID values of all the sensors found. So that would include any of these 25 or any of the other hardware-specific ones we saw that were in the 60-some thousand range for their ID values. Whatever they are, they'll be reported from available sensor IDs here. If I go back to sensor text for a second, see that update constant data. You can see some of the functions that are available, like getting the name, the vendor name, version, power usage. Almost always report 0. That's what the hardware gives you, though. Some of them report a different value. The resolution of the data that can be queried, the min and max delay on updates for the data, and get type is really, this should be the same value as what we're passing in here. But that's a function you can query from the Android API, so I made it available in Unity as well. Then in my update, we can see I'm calling sensors.get values and giving it that ID for the one I want. This will return an array of floats always. It doesn't matter what type of sensor it is, you always get an array of floats as its values. And you have to use that according to what sensor you're dealing with. But here I'm just printing that out so you can see some string formatting for the text, but I'm just returning it directly. For most sensors, I think these sort of raw access functions are going to give you everything you need. You're not really, for the light sensor or proximity sensor or something like that, there's not a whole lot going on. If we go check those out again over here, turn my device on again. So say like the light sensor, this value is just the amount of lumens being returned. And if I move my device closer to a light source, or actually put my hand in front of the light sensor, you can see those values changing, and I just hit power. Whoops, made my device pause. Pressure sensor, again, it's just a scalar value. I can actually move it's fairly precise. I can move my device up and down. You can see that pressure value changing. Proximity here, this one's a little disappointing. See 5, that means there's nothing being detected. And if I put my hand over the device, we see a 0. There's nothing in between the 5 and 0 on the proximity sensor, at least in any device I've checked on. Number of other sensors available here. There's a couple other, as I mentioned, like the orientation can be queried from the system, as well as an estimated altitude. This estimated altitude uses the pressure sensors. The pressure sensor has to be available for this to work. And it also, to get the best results, it needs to know what the pressure at sea level where you are is. I did not know what that value was, so we're getting a value that's obviously incorrect. I am in Florida, but I don't think we're negative 19 meters under sea level at the moment. But you can see relative values. It does shake a little in my hand, but if I move my device from about chest level up, you can see those values changing, and I'm just moving the device up and down the length of my arm. You can see estimated altitude changing. So it's not a perfect result, but you could definitely use it for checking for relative altitude changes. So most of these values are fairly straightforward, but some of them are pretty complex. One of the more interesting ones, I think, is the rotation vector. And this is a quaternion being returned from Android. It's right-handed and kind of non-standard to Unity's use of a quaternion. If you're one of those people that thinks in 4 dimensions, you can look at these numbers and determine what the orientation of my device is currently. But probably this is a little bit crazy, and trying to use this value directly would be difficult. So SensorDev provides some more functionality than just accessing these raw values, specifically for the more complex sensors, such as the rotation vector. So in this function that'll be available in SensorDev, get device rotation. See, it's doing a fair amount here. I'm just going to walk through kind of quickly what's going on here, what's being handled for you. Whoops, Control-C. You can see I'm querying first the rotation vector values, checking to make sure that I have enough values. Their very old API versions would return a different type of sensor value here, and we're just not dealing with that right now. Shouldn't be anything that should happen unless you're running really old version of Android. Next, as I mentioned, the quaternion that Android provides is not directly ready to be used by Unity. We're basically switching right-handed to left-handed here. So that's the first step. Then I'm building a result that we're going to return, but we want to take into account a few more interesting complications. First, this quaternion that we're getting from Android will be identity when the screen is pointing up and the sort of portrait top side of your device is pointing north. This is probably not the orientation most people hold their phone. This would mean you're kind of looking down at your device from above usually. So we probably want the held upright, staring at your screen as though you're sitting or standing. Let's fix a typo here while we're in there. Draw attention to that during the video. But here I'm adjusting for that orientation I just mentioned. Then the rotation vector we built, and then finally I actually want to cancel out any sort of window orientation that's being changed. So if you rotate from portrait to landscape left, landscape right, or portrait upside down, I don't want the scene to actually change. So we're correcting for the possibility that the window will actually rotate and switch from portrait to landscape mode. So we'll still see the ground will still be down, no matter where down is when we do that switch. Just a little precaution here. This is just handling if an issue happened with quaternion, it should not happen anymore. But some of this math is probably a little beyond most of what somebody wants to do or deal with this thing. So this is all in a prefab object. You could just add to an object or just query this function directly to change your rotation value. And you don't have to worry about all these other complications. So that's a basic idea of what's available in SensorDev. I hope you enjoyed the presentation. SensorDev is not released yet, but will be soon. We want to clean up a few things and finish up some more documentation. Do look for it on the Unity Asset Store in the future. Thank you very much. Have a good day.